Hello guys, welcome to our class. So this is Normal Science Tutors Online, and for our class for today we are continuing our discussion on lenses, and we'll be looking at optical instruments. Okay, I said that lenses are used for optical instruments, so we are going to be discussing different types of optical instruments. We'll look at the camera, the eye, how the eye functions, the accommodation on the eye, similarities between the camera and the eye. Then we'll also look at some other optical instruments like microscope and others. Then defects of the eye, defects of vision, long-sighted and short-sighted, and then we just solve some problems. So these are what we're going to cover in this particular class. That's okay. So get your writing materials ready and prepare yourself for a wonderful time of learning. But before then, if you have not subscribed to this channel, click on the subscribe button, click on the notification bell so that whenever we upload a new video, YouTube will be notified. If you are a new visitor to this site, you are welcome. This is Normal Science Tutors Online, and our aim is to make physics to be as simple as possible for you. So if you are just coming, please join the family, subscribe to this channel, invite your friends to come and enjoy what you are enjoying. So that's okay. So you are welcome. Get prepared and get yourself ready so that we can go straight to our class for today. I am Mutable Michael, and our WhatsApp number is showing right on your screen, so you can reach us through the WhatsApp number that is showing right on your screen. Okay, so let's go straight to the class for today. So as I said, we are looking at different types of optical instrument, and one of them is a photographic camera. Okay, so the features of a photographic camera, if you look at it, has some features, and this is a lens, and then this is the focal point of the lens. Okay, so then this is the screen where the image of this object is casted by this particular lens. Okay, so a camera typically has a lens, and then it has a sensitive film that is inside here. This is the film. Then it also has a diaphragm. The diaphragm controls the amount of light that enters into the camera. Then there is a shutter. There's a shutter that a shutter of variable speed that opens up when you want to snap a picture. So these are the features of the camera, and the photographic camera lens is movable so that the distance between the lens and the film can be adjusted. So this lens is movable. Okay, the lens is movable so that you can adjust the distance between the lens and the object that you want to snap the picture. Okay, so once you are able to adjust the distance of this lens and the film, you'll be looking at it, and then this is where you view the film. This is your viewer. So you look at the camera from here, you look at the sharpness of the image before you snap. So these are the features of a camera, and this is just a simple camera. Just take note that a camera is one of the optical instruments that are in use today. Then you also have the human eye. The human eye is also an optical instrument. It is like the photographic camera that we just saw. See, the human eye has a lens. Okay, there's a lens that is in front of it, and then it has a light sensitive retina where images are formed. So these are some parts of the eye. You have the iris. The iris, the color part of the eye, responds for adjusting the amount of light that will enter the eye. So if you look at it, you find that the iris is like the diaphragm of a camera. Then you have the sclerotic layer, which is this part that covers the eye. So if you are a science student, you have studied biology, maybe you have studied the eye already, so most of these things will be familiar with you. The pupil, is the black hole. The black hole, this hole that is inside the eye, is the pupil, and that is where light passes through into the lens. Okay, so that is the pupil. Then the ciliary muscles, they are responsible for adjusting the thickness and the curvature of the lens of the eye so that the eye can focus an image on the retina. Then you have the aqueous humor, that is in front of the cornea. Then you have the vitreous humor that feeds the whole eye. It's like a liquid that feeds the whole eye, helps to lubricate the eye. Then you have the optic nerve that carries information from the retina to the brain. Okay, so it is the optic nerve that actually gives you the sensation of vision or sensation of sight. Then you have the retina, which is the light sensitive area that where images are formed. So these are some of the parts of the eyes. These are some of the parts of the eye. So how does the eye focus an image? So this will take us to the accommodation of the eye. So the eye, naturally, you find out that if you want to, if an object is very close to your eye, you find out you want to, you will almost like to want to close your eyes so that you can focus the image of the object. Then when the object is far away, you try to open your eyes, okay, so that you can also see the object. So the eye, through the action of the ciliary muscle, can adjust the focal length of the lens so that the image of an object can be focused on the retina. So the ciliary muscle are the ones that are in corners of your eyes. They help you to focus objects on the retina of the eye. So accommodation on the eye is the ability of the eye to alter or adjust the distance or adjust the focal length of the lens so that a clear image of an object at different distance can be formed on the retina. And this adjustment of the focal length of the eye is brought about by the ciliary muscles. Okay, so that is what I've also mentioned before. The ciliary muscle, I said that when an object is brought close to your eye will tend to fold, trying to adjust the focal length of the lens so that you can be able to focus the image of the object on the retina. Okay, so when the eye is unable to do all this, that's when you say that the eye has a defect. If the eye cannot focus an image on the retina, then the eye has a defect, and that defect has to be corrected. Okay, so the near point of the eye or the near point of a normal eye is the nearest distance of distinct vision, and the nearest point at which an object can be clearly seen, and this point is 25 centimeters. So the nearest point that an object can be clearly seen for the human eye is 25 centimeters. Yes, if it is getting closer, you find out that the eye will tend to shift to accommodate the image, but it will not be easy. So 25 centimeters is the nearest point. Then the far point for an eye is at infinity. Yes, the far point for an eye is at infinity. So which means that an eye can actually see very far away until the image or until the object disappears from the horizon. So that's why they say the far point of an eye is at infinity. This is the farthest distance of distinct vision. That is the farthest distance that the eye can actually see is the far point. Okay. Alright, so these are some of the terms, and then we will now also look at some similarities and differences between the eye and the camera. So these are some of the similarities between the eye and the camera. One of them is that the camera is made of a light tight boss painted black inside, while the human eye is impregnated with black pigments within called the chorioids. Okay, it's made up of black pigments within that are called the chorioids. Then you have the pupil. The pupil in the eye serve the same purpose as the aperture of the camera. the pupil of the eye it serves the same purpose. It is the pupil that allows light to enter the eye. Then it is the aperture of the camera that allows light to enter the eye too. Then number 3, both the eye and the camera have converging lens to focus rays from an external object. Two of them, both the camera and the eye, they have light sensitive material on which the rays are focused. So for the eye you have the retina, then for the camera you have the film. For the camera you have the film, for the eye you have the retina. Then the iris of the eye serves the same function as the diaphragm in the camera. The iris and the diaphragm, what they do is that they regulate the amount of light entering the eye and the camera. So take note of the difference between the iris, the pupil, the diaphragm, and the aperture. The aperture is the opening, right? It is the opening into the camera. The pupil is also the opening into the eye. The iris controls the amount of light into the eye, while the diaphragm controls the amount of light into the camera. Okay, so those are the similarities. What are the differences? These are some of the few differences. The human eye has a variable focal length, so which means the focal length of the human eye can change, while the focal length of the camera is fixed. The distance between the lens and the retina is fixed in the human eye. For the camera, the distance can be adjusted. Then the shutter of the camera opens for photographs to be taken at a time, but for the eyelids are always open. So that allows an eye to see images continuously. But for a camera it open and close. But for the eye, because the eyelids are always open, it helps to register images continuously for the eye. So those are some of the differences between the eye and the camera. Okay, so we'll still look at some other optical instruments. So the simple microscope is also another optical instrument, and this is commonly used in your school laboratory. So the simple microscope actually is a magnifying glass consisting of a converging lens which forms an erect and magnified image of a microscopic object placed between the lens and its principal focus. So if an object is placed between the lens and the principal focus, you can actually use this simple microscope to see the object. Okay, so this is a simple diagram of a simple microscope. In case in your examination you ask to draw the diagram of a simple microscope, this is the diagram that you should draw. Is that okay? So other optical instruments, we have the compound microscope. It is used to produce higher magnification of objects than that obtained with the simple microscope. It consists of the objective lens and eyepiece lens. So the compound microscope has two lenses. One is the objective lens and the other one is the eyepiece. Okay, so that is for the compound microscope. Then we also have the astronomical telescope. These are other optical instruments. Astronomical telescope. This one is used to view distant objects such as the stars and the planets, and it also has an objective lens and then an eyepiece. So these are other type of optical instruments that we have. Okay, all right, so now we'll look at defects of vision. Defects of vision. So what are some of the defects of vision? So defects of vision will have two main types, and that is a long sight and short sight. Long sight is also known as hypermetropia. hypermetropia. And what happens is that for this particular defect, the eyeball of the person that is suffering from this defect, the eyeball is too short and the focal length is very long. The focal length of the lens is very long. So for someone that has a long sight, he has a short eyeball and a long focal length. So in this case, rays of light from a near object are brought to focus behind the retina and so appear blurred. The problem with this person is that they cannot see objects that are too close. If an object is within the least distance of distant vision, the object, the image of the object will fall behind the retina. So these people can see far distance objects, but objects that are close to them, they will appear blurred. Okay, so his near point is further than 25 centimeters. So which means that he can, at 25 centimeters, he will not see a clear image, but an image that is far away, he can see it very clearly. So how do you correct this defect? You use a convex lens or a converging lens. Okay, so a converging lens, we have to bring the image of the object to the retina. Okay, so this is the long-sightedness and how it can be corrected. Okay, so I have a sample problem here that relates this defects that we just mentioned now. Okay, so this question says that find the focal length of the lens required to correct the defect of vision of a man whose near point is 50 centimeters. Assume the least distance of distant vision of the normal eye to be 25 centimeters. Okay, so for this particular question, the object distance is equals to the distance of least vision, which is 25 centimeters. Okay, then the image distance is the near point, is the near point of the mass, so and that is 50 centimeters. So images formed by the eye, they are negative, so image distance is negative. So we are asked to find the focal length. So focal length from the lens formula is 1 over f is equals to 1 all over u plus 1 all over v. So if you substitute this equation, we have 1 all over 25 plus minus is minus, so this will give 1 over 50 minus 1 over 50. The LCM was 25 and 50 is 15. So 25 into 50 is 2 and 50 into 50 is 1. So that gives us 1 over 50, and then means that 1 over f is equals to 1 over 50. So f will be equals to what? 50 centimeters. So the focal length of the lens required is equals to 50 centimeters. So this is how some of the problem comes. Okay, this is how some of the problem comes. So just take note of that. Still on defects of vision, we are looking at short-sightedness. Short-sightedness is also known as myopia. And this defect occurs when the eyeball is too long. Remember, for long sight, the eyeball is short. But in this particular one, the eyeball is long and the focal length is short. So for this case, rays of light from a distant object are brought to focus in front of the retina and so appear blurred. Look at it here. That is where the image of the object will be formed. This is your retina and this is the front. So such a person can see objects that are near, but far objects will appear blurred to him. His far point is less than the normal, which is at infinity. So I will say that the far point of an eye is at infinity. but for this particular one it is nearer than the far point, so you cannot see distant objects, but you can see objects that are close to him. So for this, you need a diverging lens to correct it, either a diverging or a concave lens. So this is the diverging lens or the concave lens to correct this defect. Okay. So this another sample question. Say that a short-sighted man cannot see clearly objects beyond 90 centimeters from his eye. How can this defect be corrected? So what you are looking for is the focal length of the lens that you use to correct this defect. Okay, so for this particular one, the object distance is at infinity. The image distance is 90 centimeters. That's what is given to you. The image distance. Okay, so from 1 over f is equals to 1 over v plus 1 over u. Substitute to this equation, it will be 90 plus 1 over infinity. 1 over infinity is equals to 0. So this will be equals to 1 over 90. 1 over f is 1 over 90. So your f will be equals to 90 centimeters. So the focal length of the lens that is required should be 90 centimeters. Okay, so this is a jam question, and just alright. So this is the focal length of the lens that is required. Okay, guys. So this is your test page. Just try and solve these problems and see how far you can go. Right. So this is where we are stopping for today. Thank you so much for your time. We appreciate you. Please, before I go, click on the subscribe button. If you are just visiting for the first time, click on the notification bell so that when we upload a new video, YouTube will notify you. Right. Also, give us a thumbs up, give us a like, invite your friends so that they can come and enjoy what you are enjoying on YouTube. So thank you so much. We appreciate you. If you have any challenge, reach us through the WhatsApp number that is showing on your screen. I remain Optical Michael. This is Nobleman Science Tutors Online. Thank you so much, and we hope to see you in our next class.